Hi everyone, I am Ariful Anik. I'm a first year PhD student at the University of Manitoba and I'm happy to present our paper Data-Centric Explanations Explaining Training Data of Machine Learning Systems to Promote Transparency. Machine learning algorithms are used in a range of automated systems we use in our life. Most of these systems are data driven, which means that they work based on the data they have, which is necessarily the training data of the system. However, the challenge with this approach is that someone has to pick this training data, and owing to the limitations of resources and availability, sometimes these data are not accurate and they are not representative of the population who might be using the system. This leads to several performance issues and biases that we see with existing machine learning systems. For example, most face recognition softwares seem to perform poorly for people of color. Now, one explanation to this is that the systems has been trained with images of mostly white faces which are not representative of the population. Now, despite the importance of training data, for a number of stakeholders, the training data and the training process is a complete black box. They don't have any information on it. To provide transparency into this training process, in our work, we present training dataset information to potential end users of the system, and then we study how this information might impact their perception of machine learning systems. Now we presented this information through an explanation prototype where the goal of the prototype was to communicate important information on training data, including how the data was collected and what data was used in the system. We grouped information about training data into 5 categories, where for every category we provided some overview information. Within each category, we presented the information in a Q&A based approach so that the reader can easily focus on the information that they're particularly interested in. On the right, you can see the questions and answers for the demographics category, where the prototype in particular is displaying the gender distribution of the training instances. We evaluated our prototype in an user study where the goal of the study was to explore how this explanation impact users' trust and fairness perception of machine learning systems. We conducted the study with 27 participants where we explicitly recruited participants with a range of expertise. Participants interacted with a number of explanations from example systems where we varied the stakes of the system, ranging from low to high stakes, and also the quality and the balance of the training data presented into these explanations. We used questionnaires and semi-structured interviews to collect data from our participants. Our study data shows that these explanations are positively received by participants, and they have a positive impact on end users' trust and fairness perception of the systems. Participants talked about how they trust the system more because they have seen this explanation and they feel that they know more about the system. Among all the information presented, participants found the demographic information to be the most useful, and they talked about how it helped them to identify any potential biases in the system. For example, this participant mentioned that since 90% of the data were from male, they can easily conclude that the system would perform better for men. Additionally, we saw some interesting insights that machine learning experts might be underestimating the capabilities of general users of machine learning systems. Some expert participants in our study seem to think that these explanations would be too difficult for people without any computer science or machine learning background. However, we did not see any evidence of our non-expert participants finding this information difficult to understand. To summarize our contribution, we designed data-centric explanations that communicate training dataset information to end users of the system with the goal of increasing system transparency. We also presented study findings that shows that these explanations have the potential to inform participants' judgment of trust and fairness in machine learning systems. Going forward, it would be important to explore how we can evaluate these explanations in the context of real-world systems, and in doing so, we can better understand how this type of transparency might impact users' interaction with machine learning systems. We hope that our work would motivate other researchers to work with different aspects of data-centric explanations. Thank you everyone for your attention.